Yo guys, welcome back to another video. Guys, so here we have the variant 3 for the paper. We have done variant 1, we have done variant 2. This is the last variant for the May-June. The October-November exams are coming close, so that's why I'm doing so many of these past paper questions, especially the newer ones. Yeah, so basically we will be doing this paper. I have not seen the paper, it's basically unseen for me. So you'll see how I go over each question, even after not seeing any of the questions before. So it's a blind type of test for me, as well as hopefully you. You can do this test with me, or you could have attempted it and then come here for all the questions that you got wrong. And yeah, so let's begin. I think let's not waste any time. Time is a lot of value right now because exams are coming closer, so let's just begin. Okay, let's just begin. Alright, so the table lists 5 devices you're supposed to tick to show if the device is an example of an input device, output device, or storage device. It's pretty simple. A keyboard is what? A keyboard is an input device. A microphone is also an input device. Headphone is an output device. Hard disk is a storage, an actuator. Now let's see, an actuator, technically it does stuff for you, so it's an output, isn't it? Because that's the definition of an output, right? It gives you information. Actuators give you information, so I'll put it there. There are 3 different types of storage devices. One type is magnetic, the other one is what? We have optical and we have solid state. Those are the only 3 that you need to know for our syllabus, so they make it so easy. You only need to remember 3. Okay, conversions. You see, there always has to be conversions. So we have to give a 12-bit. You see, that's people will give 8-bit and just say, oh, I'm gonna do well in this paper. And then they realize once when they get the paper, it's 12-bit. So 12-bit means 12 values. Do not write 8 values. 12 literal values. So let's see. How do I like to do this? So I like to split it into the different parts. And then I like to write 1, 2, 4, 8, and A is 10, so it's gonna be like this. 5 is just simply like this, and this one is just like this. You see now? Yeah, this is 12-bit, so this is 12-bit. Okay, so that's we're done with the first one. I'm gonna erase this. In your exam you keep it, but for now, because I have the ability to erase, why not? So 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8. C is what? C is 12. Yeah, C is 12. So 1, 1, 0, 0. 8 is simply just this, and then this one is like that. So conversions are free marks. If you've been watching my videos for long, you will know that these are just free marks. I don't count them as part of the paper. If you don't get this right, man, that's going to be a problem. You have to really focus on this because it comes in every paper and it's almost always similar, so that's why it's so, like, you know, simple. 1, 2, 4, 8. It'll be funny if I make a mistake now, but because I'm doing it so quickly, I have a feeling I'll make a mistake, but I'm hoping not. Okay, F is 15, right? So just 1 in all, and then 9 is 1, 0, 0, 1, and then 2 is 0, 1, 0, 0. Okay, yep, that should be fine. Yeah, I think that is all okay. Let me just quickly go over. Yeah, they all look okay. LED, LCD. I think you only need to know for our syllabus LED and LCD. I don't know why the syllabus is so outdated. They should change it. I don't know in 2023 if they've introduced OLED and stuff, because I know there was like OLED in the textbooks and stuff, but it's so outdated. It's so pointless sometimes. Sometimes I tell myself, why are you learning such outdated stuff when we have AI and stuff like that to worry about? But I guess, I don't know. So that's for every subject, actually. It's not only for computer science, but, you know, computer science, the syllabus has to keep updating for us to even learn valid stuff. Okay, so two reasons why LED display can be used. Now, one difference between the two is that LED has a bright screen compared to LCD. It has a bright screen, and also it uses less power, but it's giving us 2 reasons why it is being used. Okay, you could say that does not consume much power. You can say that. Also, color accuracy is really well. Longevity is there. You can also say it's compact compared to LCDs. LCDs are those box TVs, I think, right? Those are the box TVs, the old ones. That's called LCD. Two of the registers store the values, these weird looking values. Give the hexadecimal seat number that would be displayed on the screen for each of these binary values. So we're looking at hexadecimal. How do you do this? So you divide into 4-bit parts. So we divide into 4 parts. Divide into 4 parts. Above each value you write 1248, 1, 2. I have not divided this into correct. Let's see, like that. Yeah, 1 2 4 8, 1 2 4 8, and then you just write the value down. So here will be 4, here will be 0, here will be 12. 12 is C, so the answer here is 4OC. 4OC. Let's do the next one. 4OC is the first one. Oh wait, is it 4 or D? Oh yeah, sorry, it's 4 or D. See, now I just look dumb because I made a mistake, but because I was here telling you people can't make mistakes. But as long as I corrected myself, because it's 8 plus 4 plus 1, so 4D. Whoops! But we're human, we make mistakes. That's why we don't use binary. See, I just gave an example of why we don't use binary. Surely meant to do that, right? Surely meant to make a mistake. Anyway, 1 2 4 8, 1 2 4 8, 1 2 4 8, same thing. Here's going to be 0, here's going to be 7, and then here's going to be 14. 14 is E. Alright, so the answer, whoa, okay, give me a second, guys, give me a second. Yeah, my house blew up, but I'm back. So let's see. Yeah, all for the content, man. I do this for you guys. 07E, right? So we've done that. Okay, and or XOR are 3 examples of logic gates. 4 statements are given about these logic gates. We're supposed to show which statements apply to each logic gates. Bet. If both inputs are 0 and output is 0, so let's see. When both inputs, okay, what are we supposed to do, man? So there are 3 examples of logic gates. Text to show which statement applies to each logic gate. What? Some statements may apply to more. Oh, if both inputs. Okay, I was reading as if one input is 0 and the other output is 0. Okay, yeah, that makes sense. So if both inputs are 0, so that means if it's both 0, the output is 0. And no. XOR, yeah, XOR is yeah. XOR is yeah. Oh wait, or am I tripping? If both inputs are 0, okay, no wait, and is multiplication, so even this is 0. Why did I write a 0 there? Yeah, even this is 0, and even this is 0 actually. Yeah, because this is a multiplication gate. This is an addition gate. If you don't know what these terminologies are, go check that logic gate video I'll use explained here. And then XOR is like is 0, unlike is 1. Okay, if both inputs are different, the output is 1. Let's see, if it's 1 and 0, for AND gate it's always going to be 0, so we can't take that. For an OR gate we can, because 1 plus 0 is 1. For a XOR gate the output is always 1. Yeah, that makes sense. If both inputs are 1, then AND gate is 1, OR gate is also 1, XOR gate is not. It will be 0 for a XOR gate. If both inputs are the same, the output is always 0. That's only for XOR gate. No, you cannot say for the rest. Okay, we have these gates here. NOT, and OR, and XOR are all examples of logic gates. State the name of 2 other logic gates and complete the truth table. Okay, so state the name of 2 other logic gates. What other logic gates are there? NAND, yeah, NAND and NOR. Do we have to draw them? No. Okay. Yeah, I'm talking to myself, allow it. Okay, so NOR is opposite of OR gate. So how I do it, usually I just add, so I get the OR gate first and then I just reciprocate it. So this is OR gate, so NOR will be the opposite of this. Okay, and then the NAND gate, I will find AND gate, because I mean it's just easy, less chances of making mistakes. So it's like that, so the opposite will be like that. Okay, number 4, URL. Just read this part. The rest are usually irrelevant. If you can't find the answer, then you start reading this. That is what I usually tell everybody. Say the names of 3 different parts of the URL. You need to cram this, and I have also crammed it. So protocol, domain name, and then I think it's file name. This is the order also. So if you're wondering, that is the order. Explain how the URL is converted into IP address for the website. Okay, now this is a very uncommon question, but if you read your notes carefully, you would know something. It is sent to DNS. I don't know, when we were studying web pages, or when we do questions on web pages, this phrase is usually always there. So that's why I'm saying it's a very odd type of question, which then locates the IP address. Then locate the IP address. Protocol is used to state the name of the protocol. HTTP. Now, because it's secure, I'm gonna say HTTPS. I don't know if they'll give you no, they won't give you. If you write HTTP, you'll get it wrong, because they've literally mentioned that it's secure, so you cannot get away with that. And if how this protocol changes the data to transmit the data securely. HTTP, basically it encrypts it. It's another way to say it encrypts it. And also it simply just uses encryption and sends data, so no one gets to know. Okay, Harriet has a computer that is based on the von Neumann model for a computer system. The computer has a CPU. Explain the purpose of a CPU. Oh, okay, CPU. Isn't it just fetch, execute, calculations? Isn't all of that? Okay, it's just identify, so we are in luck. Okay, you can just write fetch, decode. Literally, if you just write this, you get 3 marks. Execute. Okay, now let's try to explain something. It carries out calculations. This is mainly done by the ALU, which is in the CPU. It also processes data, and this is done by the different buses and all that type of stuff. Yeah, that should be fine. That should give you 5 marks. Other components of MAR, this is a register. Okay, name of the 4 components. Okay, there's so many you can give. You can give MDR, CIR. Okay, let me write that better. MDR, CIR. Then you can give any of the buses. Data bus, control bus. There's so many. What's the other bus? The other bus is address bus. Yeah, address bus. You can write ALU, PC, CU, ACC. Yeah, all that. Describe the purpose of MAR in the CPU. MAR, if you know the cycle, MAR to MDR, isn't it? MAR to MDR. So the MAR stores data temporarily. Then it sends it to the MDR, right? Or the CIR. Let's see. PC to MAR to MDR. Okay. Anyway, well, that's not relevant. MAR stores data temporarily. And then collected by address bus. So it's PC to MAR. Okay, I've just remembered. And collected by the address bus. And then it goes to the MDR, right? Let's see. Ooh, this paper is longer, or am I just feeling tired today? I don't know. Explain what is meant by primary storage. Give 3 examples of what is stored in primary storage. Primary storage. Now, primary storage, we have RAM and ROM, right? We have those 2, which is RAM and ROM. Now, you can just explain RAM. So RAM is a volatile storage. Now, please don't structure it the way I am right now. This is just for explanation purposes. ROM is non-volatile. Volatile storage. And is directly accessed by CPU. Okay, I usually like saying that whenever talking about primary storage. They didn't even tell us to explain. Why am I? Oh, okay, no, it is. Okay, it's telling us to explain. Okay, then you can say BIOS, which is simply stores startup instructions. And then we have let's see. Yeah, I think okay. So that's 3 examples, right? The 3 examples I've given is RAM, ROM, and BIOS. Those are my 3 examples. Those are all primary storage. Yeah, I think those are the only 3 that are in our syllabus. Correct me if I'm wrong. There might be some other ones, but those are the 3 ones that I know of that are in our syllabus. The secondary storage height is damaged. Okay. So it's removed for repair. This means the computer will no longer work. No. Okay, no worries. Explain why the secondary storage is needed for the computer to work. Explain why the secondary storage is needed for the computer to work. Why do we need it? Because data is stored there. My data is permanently stored there. Hence, software cannot be loaded. Okay, so it won't start if we don't have it. Okay, take to show what type of JPEG. JPEG is an image. Now an image file uses lossy compression. Okay, you see some of these, like, such unnecessary stuff. You don't even have to read it, because you just say tick to show whether the JPEG is a lossy or lossless. Okay, simply tick it. So simple. Describe how the text document is scanned. Again, just read this, you'll get your answer. This, if you don't understand, that's how I always like to tell people. Describe how the text document is scanned by a 2D scanner. So this is how a 2D scanner works. It's pretty simple. So how does a 2D scanner work? How does a 2D scanner work? So it uses a light. So a light is shown onto document, then it is reflected back. Then what can you say? The reflected light is captured with mirrors and lenses and is converted. Now this you just have to cram. I can't explain this, right? You're supposed to cram all input and output devices. You should know how a 3D printer works. You should know how a 3D scanner works. You should know how a 2D scanner works. You should know how inkjet, laser, all that type of stuff can work. How a projector works. So I want you to go now. If you don't know that, go cram it. It'll be in your textbook. I think even notes online you can find it, and it's converted to binary. So you just need to cram that. Those types of questions you're supposed to cram. But the best way to, I think, remember those is when doing past papers, right? You go to the marking scheme and cram those answers, because those are usually always repetitive. The problem with textbooks is they just give you such unnecessary details that you don't even need, which I don't like about textbooks. Frida compresses her document. The compression algorithm she uses recognizes repeating patterns. So repeating patterns, okay, what type of compression? So a compression that uses repeating patterns is called lossless. Okay, lossless compression. So where data is not lost and uses a repeating pattern. And because they've said no data is permanently removed, that's why it has to be lossless compression. Okay, we have the last 2 questions. Today I think I'm a bit just too tired. That's why I'm just hoping this paper ends. I don't know. But describe how the data is sent into parallel simplex data transmission. So we're gonna first explain what parallel is, then we're gonna explain simplex. Okay, so data is sent multiple bits at a time down multiple wires. So that is explained what parallel means. But data is sent on one direction only. So that explains simplex. Explain why parallel simplex data transmission method is no longer suitable. Because it's 1 kilometers away, we cannot use it for long distance. Parallel cannot be suitable. It can be used but not suitable for long distances. Okay, we don't use it. And also and can be costly. Okay, with chances of data being skewed. Okay, that's why serial is the one used. For long distances, serial. For short distances, parallel. Explain why checksum and ARQ are both used. Okay, when transmitting data from a computer to a file server. So checksum, so you can just explain how checksum works. So checksum detects errors using a calculated value. I'm hoping you already know how this works. It does, before transmission works, it calculates a value, then after transmission takes place, it does the calculation again and then compares the two. Now ARQ, on the other hand, uses timing signals, so uses timeout and acknowledgements. You need to cram this. Most of CS is cramming for paper 1, that is. For paper 2, it's logic. So such different two papers, they test both your skills. And requests data again if not received. Okay, let's see, last question. The paragraph provides something about translators. A compiler and an interpreter translate high-level language. Okay, the other one, which is assembler, translates low-level language into machine code. An interpreter does this by translating and executing the code line by line. So interpreter line by line. You see, I'm not even seeing if this is an option. By the way, I should do that. I'm just assuming that's the right answer. Yeah, I can see line by line. So that's funny because some of these you don't even need the options. And a compiler does this by translating and executing the code as a whole, or let's see, all at once. Okay, I've seen all at once. All at once. One benefit of a compiler is that it creates an exe file, which I see right here, executable file, but interpreter doesn't, which means that the translator is not required. Not required. Each time to run the file, is easier to do with an interpreter because it stops translating the error, so it does debugging. Is it here? Yeah, debugging. I saw it, that's why debugging. Yeah, so that marks the end of this video, this paper. Pretty straightforward again. Most of these past papers, I think, if you know your content, you shouldn't worry. So I'd advise you to go over all the different topics. Maybe tomorrow is 12th, isn't it? So tomorrow I will upload a video going over the recap of the syllabus, so stay tuned for that, because the paper is on 13th. I'll go over that, so go watch that video, put the notification bell, subscribe, do all that type of stuff, and I'm looking forward to see you in the next video. So good luck in your preparations, and I'll see you in the next video.